All right, let's try this problem. Here they tell us that we have 2 grams of sodium hydroxide that's put in 100 grams of water. That dissolving process causes the temperature to increase from 22 degrees Celsius up to 29.8 degrees Celsius. They'd like us to calculate the enthalpy of dissolution, or the enthalpy for this dissolving process, in units of kilojoules per mole of sodium hydroxide. So let's analyze the problem. The first type of problem you've encountered is where a hot object meets a cold object. That is not what we have here. We don't have hot sodium hydroxide hits cold water or hot water hits cold sodium hydroxide. Instead, what we have are 2 things that come together and there's a reaction or dissolving. So the way we start that type of problem is we again say heat lost is negative heat gain. There's a transfer of energy, but the transfer of energy occurs between the reaction and the surrounding solution. So we're going to start off by saying heat that's lost by the reaction. It's technically not a reaction here, but we are rearranging bonds. We're going ahead and breaking apart ionic bonds between the particles in that solid sodium hydroxide. We're separating water molecules and we're reestablishing new forces. So we're rearranging bonds. That's going to release energy. The thing that gains that energy, so this equals a negative heat gained, well, everything in the cup is going to gain that energy. The water molecules that all this stuff is floating around, and the little ions that are still floating around inside that water, they're all going to gain energy. So we say heat lost by the reaction is negative heat gained by the solution, everything in the cup. Okay, now the variable we want is this heat of reaction. This is going to give us the heat lost by the reaction in joules, and then it's just a quick change to make it into kilojoules and divide it by the moles of sodium hydroxide. So leave this variable alone. We're going to say heat that's lost by the reaction is negative. Our solution is just going from 22 degrees to 29.8 degrees. It does a temperature change. So this is going to be negative MCAT of the solution. Now, heat lost by the reaction is negative mass of the solution. This includes everything in the cup. It includes the 2 grams of sodium hydroxide that we dissolved and the 100 grams of water. So total mass, that's always what we want to use, is 102 grams, 102.0 grams. The specific heat capacity, they tell us to use 4.18, just like water. So we're going to use 4.18 joules per gram degrees C, and our temperature change. Our temperature change was, we went from 22 all the way to 29.8. So if we do T final, 29.8 degrees, 80, minus a 22.00 degrees Celsius, what we end up with basically there is 7.80 degrees Celsius. Okay, units of Celsius go away, units of grams go away, and if you do this on your calculator, you're going to get a heat of reaction equal to negative, let's keep 3 significant digits here, negative 3,330 joules. All right, let's first talk about that negative sign. So the negative sign means we have an exothermic dissolving process. That makes sense. When our bonds are rearranged inside of that reaction container, that energy is released to the surrounding solution. That causes the water, that's where the water is the surroundings. It causes the temperature of that water to increase. That makes sense. Now, right now we have units of joules. Cool. But what we really want is kilojoules per mole of sodium hydroxide. So let's start by changing the joules into kilojoules. I'm going to go ahead and do a little conversion here. I'm going to get rid of joules. There are 1,000 joules in 1 kilojoule. That leaves me with negative 3.33 kilojoules. Now we want kilojoules per mole of sodium hydroxide. That makes sense because your enthalpy change is really the heat of the reaction divided by the moles of the thing that reacted or dissolved in this case. So we need moles of sodium hydroxide. Okay, in order for us to get moles, we need to change the 2 grams that we had, 2.00 grams of our NaOH. We need to change that into moles. 1 mole of sodium hydroxide has a molar mass of 40 grams. 2 divided by 40, grams are gone. That leaves us with 0.0500 moles. We have our kilojoules, we have our moles, we can get kilojoules per mole. We're gonna take our heat, negative 3.33 kilojoules, divided by our moles, 0.0500 moles. And when we take negative 3.33 divided by 0.05, we get negative 66.5 kilojoules per mole of our sodium hydroxide. I hope that helps. Take care.